structure. It changes as the dimension of, as the location of that structure changes, the local axis will also change, but the global axis remains the same. Okay. We can set the background color. I am using here white background. Then start default design codes. For steel design, we are using IS 800. There are many codes available here. We are using Indian Standard 800. For concrete design, we are using IS 456. 456. For aluminum design, there is only one option, so US code. For timber design, also we are using American code. For shear wall design, we are using IS 456. Then accept. Okay. Next one is backup manager. This is an option to automatically save the structure. We can select the frequency of auto save. That means within how many minutes we to auto save the project. I have it is already set that 5 minutes. So in between 5 minutes, the structure will automatically be saved. Okay, then nothing to do with this. Okay, next is license management. If there is any issues regarding the license, we can move on to this license management. Next, help contents. Okay, this is help content. They have many options, like if we have any doubt regarding any usage of this software, or to give any loads and all. If there are any doubts regarding design codes, graphical environment, STAAD Pro editor help, additional modules, application examples. Okay, there are many options. For post processing mode, steel design mode, foundation design. Many options are there. If we have any doubt, we can just come here and check whether whatever we want. Okay. Now we can move on to the new project option. This is another window we get when we move on to new project option. Here we can edit the file name. I'm giving stat. We can choose the file location. Okay. Then there are 4 types of structures we can create. First one is space structure. It can accept any configuration of model geometry and loading. It permits 3-dimensional structures. It permits load and deformation in all the 3 global axes. Next is plane structure. Plane structure accepts only 2-dimensional structures. All loads and deformations are along the plane of the structure. Okay. Next one is floor structure. It accepts only 2-dimensional models, but the loads and deformation are perpendicular to the plane. Okay. Next one is truss structure. It permits loading in any direction. It permits 3-dimensional structure modeling. It permits deformation in all the 3 global axes. Okay. Then we can select the units. Units for length is SI unit is meter. So I have selected meter. For force, kilonewton. I'm going to select space frame. Then next. Okay. The next window is where do you want to go? There are some options. First one, add beam option. We can directly go to geometry and add beams. Next is add plate option. We can directly open the window to directly model plates. The next add solid. If we have to model solid structures, we can choose this option. Then open structure wizard. I will tell after opening that. Then STAAD editor is a like node page, like a programming page, so we can edit on STAAD editor to create the models. Next is edit job information. We can edit the job information. I'm going to select this one and finish. It's the startup window. This is what is called job information. Since we have selected that, this automatically came. We can edit this accordingly. We can provide the job title, line name, everything, whatever we want. Okay. Okay. Next one, about this. This is the menu bar. This file, edit, view, tools, etc. These are termed as menu bar. Then next is toolbar. This is called the toolbar. Then here on the left side, it is page control. And this is the main window where we can model the structure. Then this area is called the data area. Okay. Then we can model the geometry. From menu bar, there are many options. We can select the new project from here. We can open an existing project. We can close the project. Open from archive. Archive means while we are doing creating models and analyzing, the software may automatically generate some other files also, backup files. These all files can be saved in just one folder and we can archive it. That is from where we can open from archive. Then project wise, it is the cloud storage. Since I have no project in the project wise, we cannot open it. Okay. And open backup manager means we have so that earlier this window backup manager. Then view input command file, output command file, etc. In job information is this one. A report setup and all after analyzing only we can get. Then edit edit input command file. This is the STAAD editor. We can edit to create models, but it's better to draw it. Okay. The next is view. There are many options for viewing. We can zoom. We can view just selected objects only. We can view the whole structure, diagrams. Only after modeling we can use that. Tools, calculator, unit converter, dimension beams. There are many tools. Okay. Then select. We have drawn model. We can select using this select option, or we can select from this page control, or we can select using this cursor. Okay. Then geometry. There are three different methods to model geometry. First one, we can select from here, snap or grid node. We can add beams from here. Or we can select that SAP grid or beam from here, or we can select from here geometry option. Okay, there are three options for selecting that. Then we can directly draw the beams like this. Then we can press escape. If we have to again draw this, we can press here snap node or beam option, and then we can start drawing. If we press control button and draw, only nodes will be created. Nodes means in the software, node means they have referred to beam joints or beam column joints. They are referring it as nodes. For beams and columns, they are referring it as beam only. Then for slab, they are referring to it like plate. Solid means three-dimensional solid structures. Surface means like floor surface and all. Okay. There are three different types of grids. We can edit the grid option. Here, from origin, there are 10 grids means this is on x-axis and this is y-axis. We can edit that. Since this is xy plane, the grid will be like this. We can select xz plane or yz plane up to our need. And if I select xz plane, it will be like this. Okay. Angle of plane can be selected. We can give angles. Also, we can select origin like this. Then the origin have moved to that node. Okay. I'm giving origin 0, 0, 0. Okay. Then we can edit here also. Accordingly, if we want for spacing as 0.5, we can provide that one. Horizontal axis, we can edit here. Okay. Next one, we can create another grid. So we have to choose this option, create. Here it is linear grid. Next one is radial grid. Here also we can select the plane. First we have to name that. I am giving R grid. Okay. Select the x plane. We can select the origin. If not, okay. If we create, I am going to create. Okay. Then select this one. This will be the radial grid. We can edit that also. We can increase the number of bays. This means that uh, this is the bay. First bay is this one. The circle will be divided accordingly. Next one is concentric circles. Okay, we can edit that also. Okay, next one is create irregular grid option. I'm going to give I grid as name. Here also we can select any node as origin and giving XZ plane only. We can give the distance 0, space 5, space 3, space 4 in the x direction and 0 space 4 space 2.5 space 6. Okay, and if we select, that grid has come. Okay, this is the grid. Then if we choose snap node or beam option, we can directly create the model. Okay, so I am going to first deleting, select the whole structure, just press delete option. Okay, yes. From node cursor, I am going to select the nodes, delete, yes. Okay, everything I have model has been deleted. Next one, I am going to model just a bit. Okay, then we will see the STAAD editor. We can choose it, STAAD editor from this. Look, it means unit we have given meter, kilonewton, then join coordinates. This means we have two nodes. Look, join coordinate means join 1 is 0, 0, 4. Coordinate means x equal to 0, y equal to 0, z is equal to 0. Then second node 2, that is x is equal to 3, y is equal to 0, and z is equal to 4. Okay. Remember incidences means the beam we have drawn. That is the first beam that connects node 1 to node 2. That is 1, 1, 2. Okay, finish. Since we have only drawn that, STAAD editing commands is finished just by this. Okay. Then for adding beam, there are different options. Add beam from point to point. If we have to select this option, first we have to create two nodes. Okay, I'm going to create two nodes. From here, I am selecting again. For creating node, just press Ctrl and create the nodes. Okay, two nodes are created. If we close this, the grid will be disappeared. Okay, then I am going to create beam, add beam from point to point. Just pick 2 points. The beams will be created. Next option to create beam is add between midpoints. So when we select this beam, the beam will be starting from the midpoint of that beam. And if we select this beam, it will automatically end at the midpoint of this beam. Next option is add beam uh, by perpendicular intersection. Okay. First we have to select the node. Then if I want a beam perpendicular to this beam, just select that beam. Okay, since intersection point is outside, it won't come. Okay. I'm going to select this one and this one. Okay. And beam by perpendicular intersection. I'm choosing this one. I want, look, this beam is perpendicular to this beam. While we are creating uh, beams or nodes, this it will automatically show in this data area. This is coordinate system. Also, we can edit from here. If we edit, this means node. Here are 1, 2, 3, 4, 5, 6, 7. 7 nodes are created. X, Y, Z coordinates. This is automatically generated. Or else we can give the coordinates here, and the nodes will automatically be created here. This means we have drawn 1, 2, 3, 4, 5, 6, 7 beams. 1, 2, 3, 4, 5, 6, 7. 7 beams. First beam is connected between node A and node B. Second is connected between node 1 and 2, first beam. Second beam is between node 2 and node 7. That's how it can be read. Okay, escape. Uh, this is one method by which we can model geometry is grid method. Next one is by giving coordinates, user coordinate method. Next one is I'm going to delete this model. Next method is we can model using run structure wizard option. Here they have created some models. These are truss models. Just drag over here. We can edit the option. We can provide whatever length, height, or width according to our needs. We can provide a number of bays along length, number of bays along width. Apply. Okay, this will be created. If we want this to that a main window, just close it. They will ask whether would you like to transfer or merge this prototype into STAAD Pro. Yes. Then we can select the coordinates. Okay, this has key. Okay, different options are truss models, frame models. This is bay frame. Okay, this is how we create building geometry like bay frame. Okay, beams and columns. Then grid frame is there. Apply. This is a grid frame. Okay, cylindrical frame, circular beam. Then surface of plate models. There are different models available here. Then solid models. Solid block is available. Then bunker or silo. Composite models. Then we can import from AutoCAD models. Okay, VBA macro models. Stadium roof. Okay, this is a simple tower. Okay, these models are already saved. Okay, we can close it. I don't want this, so I'm giving no. This, close. I'm going to delete this. Yes. Okay, everything is deleted. Next one is I'm going to model a beam. And we have some tools here. If we want to insert node, we can insert node here. First select that beam. New insertion point, we can give a distance, say 2 meter. Add new point. Okay, a new node is created. Then the beam is split up into two beams. Okay. Then select this beam. We can stretch that beam. From this option, or from here we can select it. Stretch selected member. We can stretch to a point like XYZ coordinate or through a distance, just start node or end node. Okay, I'm going to stretch the end node by 2 meter, then okay. Or we can stretch to an existing node if there is an existing node here, or we can stretch to an existing member. Apply, close. The beam has been stretched to at a distance of 2 meter. Okay. Then we can cut cut this beam. Okay. Yes. The beam has been cut. We can paste wherever we want. This is the paste option, or we can paste from or Control V. We can press. We can give the coordinates, like I am giving x as 3 and z as 2. Okay. Look, that beam came here. Then there is another option to copy, paste, etc. Just I can copy this way. This is copy option, or we can select from. Oh, there is. Okay, just copy. Then we can paste here wherever we want. X coordinate 1, Z 3. Okay. Look, another one came. Sorry, I have cancelled that. Okay. Next, we can do meshing if we have created a plate. There are many tools. Then I will show to analyze a beam. Okay. Then I'm going to create XYZ, XZ plane, YY. Okay. Okay. And I'm going to create a beam of 8 meter. I will close this. This is the different views. We can rotate also with respect to any plane. There are 1, 2, 3, 4, 5, 7 options to rotate. There are different views. This is front view. This is back view, side left view, right view, top view, bottom view, three-dimensional view. It's better to explain with another one. Okay, I'm going to delete this. I'm going to select a geometry from structural wizard, one frame model. Okay, apply. We can edit that. Okay, this I'm merging this. Okay, okay. This is a three-dimensional view. Front view will be like this. Then back view, left view. Since we have selected that 12 by 12 meter. That's it. Top view will be like this. Bottom view, three-dimensional view. Okay. For analyzing, uh, first we have to geometry. Okay, we have to model the geometry. Then we have to give the material properties. Then we have to assign the properties to that model. Next, we have to give support. Then we have to give load, and then only we can analyze the structure. I will show an example with a beam. I'm going to create a beam, 8 meter. Okay, and give it front view. Okay, from here, from commands, first we can give properties, user defined table. Okay, this will be, this window will come. Or I can select from general option. Okay, then first we have to define the property. I'm going to define it. This is a beam. Uh, First of all, just 3D rendering view. I'm going to select this one. This is shown as a line. Okay, we can go to 3D rendering view from here also. Like, okay, I'm going to create a the create properties rectangle. Depth is 0.3 meter and width is 0.25 meter. I'm going to add material. We can select steel, stainless steel, aluminum, concrete. I'm selecting concrete. Add, then close. 0.3, 0.25, add, close. Okay. Then we have to assign this property to this beam. There are 4 methods to assign. First, we have to select this one and assign to selected beam. Since we have only one member, we can use assign to view option. If we choose this option, it will automatically be assigned to this one. Then assign to edit list means we have to number the beam number we have to give here. Just one. This is beam 1. If we have to see the number of the beam, just press shift plus B option. Okay, if we again press shift plus B, it will be gone. If we have to see the number of nodes, just press shift plus N option. This nodes numbers are displayed. Again press shift plus N, it will be disappeared. Okay, then I'm going to assign this, assign to, or you can use cursor to assign, just press assign and select the beam. The property was assigned. Then if we look the 3D view, it will be like this. Since I have given length and, width and breadth, it came like this. Okay. Then after assigning the properties, we can close this window. Okay. Next is to provide support. We can assign property from here or from this. From here, page control, from toolbar, or from menu bar commands. Okay. Next one is support specifications. We can select support from here, from that is menu bar, or from here, or from here. Okay, this is the support window. First of all, we have to create the support. I am giving a fixed means fixed support, pinned means simply supported. So I am going to give a simply supported view. To add, support is created. Here also there are four methods to assign. First, if we select this node, we can assign to selected node, or assign to view. Use cursor to assign to edit list means we have to number the nodes. I am going to give number 1, space 2, and look, support has been assigned. Escape. Next is we have to give, since we have no specifications, I am not giving any specifications. I'm going to assign load. First, we have to add load case details. Add that load. I'm giving as DL add. I'm not giving any other loads. If we have to give any other loads, we can just select live load and we can give title and just add. We can select win loads, is big load, any other loads. Okay, close. We can delete from here also. First dead load, add, again add load. First one is self weight. We have to assign self weight. The factor is -1 because it is in a negative y direction. Just add. Then another dead load is one member load. I am giving a concentrated force of -2 kilonewton. I am going to give at a distance d1 means 4. That is, this is the distance. d1 means from starting to at which point load is applied up to that distance is d1. This is on global y direction, so I am going to add this, then close. Then we have to assign these loads. Since I have only one member, we can assign like assign to view option. Select assign to view, assign, yes. Or just select the beam, assign to selected beam, assign, yes. Load has scale. We can scale. This is the option for scaling. Just click on apply immediately option. The size will change. Okay. Apply. Okay. After giving load, the next step is to analyze. First, we have to give analysis command. From analysis, click on to perform analysis. Then select all option. Okay. Then from analyze, run analysis. There are 0 errors, but one warning and one note is there. We can look what is the warning. View output file, done. This is the STAAD editor output viewer. Very weak string added for stability. Okay. This warning has came because this is statically indeterminate structure. We can make this one statically determinate. For that, I'm going to select this support. I'm going to delete the support first. Okay. Then create one pin to support, add. Then I'm going to create one more. I'm releasing fx, add. Two support having created. Use cursor to assign. I'm going. Okay. Plus we can see the loading diagram from here. If you want to see the dimension, we can click on to dimension, display, look, 8 meter. If you don't want to see dimension, just uh, click on to remove option and remove. Okay, we have already gave command perform analysis. If we again give it, there will be warning. So just analyze, run analysis. Now there is zero error, zero warning, zero note. Since this is statically determinate structure, then go to post processing mode to view the results. Done. Okay. Okay. These are the results. This is the displacement diagram. Since we can't see it, just scale it. Apply immediately. Displacement. Now it is visible. Okay. Displacement will be like this. Okay. Then next is I will please say. Okay. Okay. Next, axial force, then shear force in y direction, shear force in z direction. These are the values of the result. Torsion, bending in y, bending in z direction. These are the values. For designing, we have to choose the maximum shear force value and maximum bending moment value, and then we can design accordingly. Okay, this is how we can model a beam. Next, I will show how to model a building. I am going to close it. Again, open a new project. Base frame. Next. Mm, open structure wizard. Finish. Okay, I'm selecting frame model. Bay frame. Just length is 12. Height is number of feet. We can edit here also. Okay. We can give the height of the building. And here also we can edit accordingly. I'm going to give height as 9, 9, this 3, width as okay, 9 only, 3, okay, apply, just close it, yes, okay. Not giving any job information. I'm going to directly assign properties, define properties, rectangle, 0.3 by 0.25 and for column I'm going to assign as 0.3 by 0.3 and close. Okay. First we can select it. Select selection. Okay, we can select beams parallel to X and select beams parallel to Z, and we can assign the property of beams. Assign to selected beams. Assign. Yes. Okay. The next one, just select beams parallel to Y. Then assign to selected beams. Assign. Yes. After assigning, I'm going to front view. Then we have to assign support, create support, fixed, add, and use cursor to assign, or just select uh, nodes. Okay, assign the selected nodes, assign. Yes. Okay, just look onto 3D. Okay, support have been assigned. Then close. Next is I'm going to give load, add, load, sorry, that load, eval, add. Then next is live load, L, add, close. That load I'm going to add self-weight, add, then member load. I'm going to give a uniform force of 15 Newton per meter, add, close. Then live load, add, I'm going to give as minus 5 kilonewton per meter, add, close. Then we have to assign self-weight. Since all members have self-weight, just assign to view option, assign. Okay. Then just select the beams. Whatever you want. Since there is nothing on the top of it, I'm just giving these beams. Assign the selected beams. Assign. Okay, that load key. Live load also we can assign like that. Assign to selected beams. Assign. Yes. Next commands. Analysis. Perform analysis. Or okay. Analyze. Run analysis. Okay. Go to post processing mode. Done. Okay. Look, we can scale and look the deflections, displacement. The displacement of the building will be like this. Okay. This is axial force. Since we have column, this will be axial force will be like this. This is the shear force diagram, y direction, and the shear force in z direction. Here are the values. Then this is a moment. Okay, we can scale it to see this. Okay, this is the bending in z direction. Okay, these are the results. Okay, that's all for today. This is the introduction to STAAD class. Thank you. I'm winding up the class. Thank you, everybody.